This video is going to talk about taking the derivative for bases other than e. To evaluate the derivative of a logarithm or exponential with a base other than e, you basically have three options. Number one, you can convert to base e and use the rules for base e. Number two, you can use logarithmic differentiation, and there will be some cases where you'll have to do this, but we'll talk about that a little bit later. There is a video that goes into a lot more detail on how to do it. Or number three, you could use the rules in this next theorem. So if we let a be a positive real number not equal to 1 and let u be a differentiable function of x, the derivative with respect to x of a to the x is equal to the natural log of a times a to the x. The derivative of a to the u would be the natural log of a times a to the u times u prime, or du over dx. The derivative of the log base a of x would be 1 over the natural log of a times x. And the derivative with respect to x of log base a of u is 1 over the natural log of a times u prime. So I'm going to prove the first one just kind of using the fact that a to the x is e to the natural log of a times x. And this will kind of show you how you would use that first step as well if you wanted to convert to base e. So the derivative with respect to x of a to the x, we know that that's equivalent to the derivative with respect to x of e to the natural log of a times x, because those two are equal. So if we let that be the derivative with respect to x of e to the u, we know that the rule here says we're going to get e to the u times u prime. Well, if my u is the natural log of a times x, the natural log of a is just a number, so u prime is going to be the natural log of a. So this will give me e to the natural log of a times x, because that's my u, times the natural log of a. And if I just rewrite this a little bit, that's the natural log of a. And then this part right here is a to the x. So that would be a quick proof of that theorem, or at least part of that theorem. So when we go to use these, we can either do that process or we can use the formula. So in this case, my a is 3. So if I wanted to just use the formula, this would be the natural log of 3 times 3 to the x, and then you're done. Or if you don't remember the formula, this would be the derivative with respect to x of e to the natural log of 3 times x, which would be the derivative with respect to x of e to the u, where u is the natural log of 3 times x. So this will be u prime e to the u prime is the natural log of 3. So this would be the natural log of 3, and then e to the natural log of 3 times x, or natural log of 3 times 3 to the x. Either way, you get the same answer. It's just whether or not you have the formula learned. Now with this next one, if you wanted to use the formula, you could say that's 1 over natural log of 3 times x, and then you're done. Or if you don't know the formula, this would be the derivative with respect to x of the natural log of x divided by the natural log of 3 using that change of base formula. I could bring 1 over natural log of 3 out because that's a constant, and that's the derivative with respect to x of the natural log of x. So this is 1 over the natural log of 3, and the derivative of the natural log of x is 1 over x. So that's 1 over natural log of 3 times x, and that would be my answer. Now with this next one, this is going to be a 2 to the u or an a to the u, so we're going to have the derivative with respect to x of a to the u, sorry, I don't want to use a, I want to use 2 to the u, where u is equal to 7x. So if we wanted to use the formula for this one, we know that that would be natural log of 2 times 2 to the u times u prime. U prime here is going to be 7. So this is natural log of 2 times 2 to the 7x times 7. And most people will write the 7 out front. So 7 natural log of 2 times 2 to the 7x. And you can go ahead and fold that in and make that 2 to the 7th power if you want. There's no reason to or not to do that. It just kind of depends on your preference. Notice that the 7x stays 7x. That doesn't change, just like with e to the x or e to the u. In this case, again, we're going to have the derivative with respect to x of a log base 4 of u. So we got a u substitution where u is sine of x. So u prime is going to be cosine of x. And this one is 1 over the natural log of 4 times u prime. So it kind of forms that u prime over u relationship, but you've just got the natural log of 4 stuck out there. So in this case, that's going to be, let's see, cosine of x over the natural log of 4 times sine of x. And the cosine over sine gives me a cotangent of x, and I'll just leave the natural log of 4 on the bottom. So that would be my answer there. And in this one, my u would be x squared plus x. My u prime would be 2x plus 1. So this one is going to be, again, the derivative with respect to x of a logarithm of u, log base 5 of u. Now, I'm going to do this one from the other approach, so I could make this the derivative with respect to x of the natural log of u divided by the natural log of 5, just to kind of show you get the same answer. So I get the derivative, or 1 over the natural log of 5 times the derivative with respect to x of natural log of u. So that's times u prime over u. So that's going to be 2x plus 1 divided by x squared plus x. And there's really not any way to simplify this, so we're just going to clean it up a little bit. So that would be my answer. And you would get the same answer if you worked it out just using the formula. Now we're going to take a look at we're going to take a look at the integrals of bases other than e. So if we know that the derivative with respect to x of a to the x is the natural log of a times a to the x, and we want to use that to find the integral of a to the x with respect to x, I'm going to start by taking the integral of both sides with respect to x. Using the antiderivative, this is just going to be a to the x plus c, because the integral with respect to x of the derivative with respect to x gives me the function plus or minus a constant. And I'm going to call this c star, just because I might not use it as my final c. Here I'm going to bring the natural log of a out and have the integral of a to the x dx. Now here's where this gets a little weird. This is what I want. And I've almost got it. I can solve for it by dividing by the natural log of a. So on the right hand side I have the integral of a to the x dx. On the left hand side I want to get some kind of function plus a constant, since it is an integral. So if I write this as 1 over the natural log of a times a to the x plus c star over the natural log of a, this is just a constant. So I'm going to call this 1 over the natural log of a times a to the x plus c. And that gives me the integral of a to the x dx. So this is my answer right here, and this is the formula for the integral of a to the x dx. So we're going to use this to do some integration. In this case, the formula here would tell us that this is 1 over the natural log of 3 times 3 to the x plus c, and there's nothing wrong with that. But if you wanted to not have the formula memorized and just try to work the problem as is, you could write this as the integral of e to the natural log of 3 times x with respect to x. So this would be the integral of e to the u with respect to x, where u is the natural log of 3 times x. So u prime, or du, which is u prime dx, would be the natural log of 3 dx, and we need a natural log of 3 here. So I would multiply by the natural log of 3 divided by the natural log of 3. I would bring one of them to the inside. And that would give me the integral of e to the u with respect to u times 1 over the natural log of 3. And we know that that is just e to the u plus c. So when I plug the u back in, I get 1 over the natural log of 3